Hi, today's lesson is going to be on using geometry and electric guitars to look at mathematical ratios, equivalent triangles, and doing a geometric construction. So first off, a little bit about the tool we're going to use. We're going to use a stringed instrument, whether it's a ukulele or an electric guitar. But on a stringed instrument, you pluck a string and it vibrates from here to here and makes a note. And if you want to make a note one octave higher, you go down 12 frets and you make a note that is one octave higher. And each step is going down one note, but if you notice, they aren't spaced evenly. And that's the part that we're going to work on. If you can come in here and take a look at this, we're looking at a mathematic ratio. And this number is going to be important to us. 2 to the 1/12 is 1.0595. And the algebra is a bit messy, but the 2 comes from the fact that when we are 1/2 of the length of a string, we're one octave higher. And the 12 comes from the part that there are 12 steps to get to one octave. But if you plug that into a calculator, you get a number, 1.0595. That's going to be useful to us. The next thing we're going to do is look at how that affects fret spacing. So I'm going to take this ukulele and exchange it for something bigger to work with. This is an electric guitar that I'm working on. And the string goes from here to here, which is 25.5 inches. So we're going to take 25.5 inches and divide it by 1.0595, our number from 2 to the 1/12, and get a length of 24.068 inches. That's telling us that if this is 25.5 inches, this should be 24.068 inches to the first note higher. So if we take 25.5, subtract the 24.068, that tells us that this space here should be 1.432 inches to the next higher note. That's where our ratio comes from. For every certain amount of length, in this case 25.5 inches, we need to reduce it by a certain amount, in this case 1.432 inches. Those two numbers are going to set our ratio. And we're going to use the concept of equivalent triangles to build our geometric construction. Our equivalent triangle is going to be a right triangle. This length down here is going to be the 25.5 inches of the original length of the string. This length up here is going to be the 1.432 inches of that amount that we have to reduce it. Then we're going to draw a hypotenuse, and with side-side angle, equivalent triangles, we're going to build our way down the neck. So to do that, I'm going to start by drawing a straight line 25.5 inches long. This is a straight edge. It's not a ruler, it's just a straight edge. So I take a pencil.
Do you want me close?
Yeah, you may want to come around this side. So I'm just going to draw a straight line. Then I'm going to mark my starting point, and I'm going to measure off 25.5 inches. That is right here. That is my 25.5 inches of the string length. Then I need to measure out 1.432 inches, which isn't terribly easy to do, but 1 7/16 is 1.438 inches, and for what I'm doing, that's going to be close enough. So I take a ruler in my dividers, and I come down and I expand it out until I am 1 7/16 of an inch. Then I put my compass right at the start of my line, and I draw an arc. Then I draw a line perpendicular to my base to make it a right triangle. So now this is a right angle. This is my 25.5. This is my 1.432 inches. Then I have to construct my hypotenuse. Now I'm all set. I have my right triangle. I know where that first fret is going to be. That's where my curve came down and hit it. So my first fret is right here. To figure out where the next fret goes, I'm going to use this same ratio, and I'm going to make a new equivalent triangle. All I have to do is line up with that first fret, draw a new vertical, and now this triangle is equivalent to this triangle. And now I can take my compass and I can readjust it. See how it's longer than this hypotenuse? So I can crank this down until it just matches that. And now I take and I swing an arc down. And that's where my second fret will go. It's the same ratio, but it's just a little bit shorter. And I can keep doing that, working my way down the neck. I draw my right angle. I readjust my compass. I draw my arc. And that's where the third fret goes. And you can work your way all the way down the neck. And you can see how well you did by putting your guitar neck up to it and seeing this is where the string starts vibrating. This is where the first fret goes. This is where the second fret goes. This is where the third fret goes. And you can work your way all the way down the neck. And it works with any scale length. You just put in the length of the string, the length to the first nut, first fret, and just work your way down. So that covers mathematic ratios, equivalent triangles, and uses a geometric construction to build a musical instrument. Thanks.